Welcome viewers. In this video, we'll see the performance of the RL series circuit. When the resistance, pure resistance and pure inductance is connected in series, it is called the RL series circuit energized by the AC supply voltage. We are going to analyze the performance of this circuit, RL circuit. What is the voltage, equation for voltage, current, phase angle between voltage and current, power triangle, impedance triangle, power factor. These things we are going to analyze in this RL series circuit. So in this RL series circuit, this R and L is connected in series, energized by the AC supply voltage. It's a current I. Because of series circuit, the same current is flowing through R as well as L. The current flowing through the R and L is same current is flowing. Now we'll consider this V equal to Vm sin omega t, applied voltage. So I is the effective value at any instant. Small I is the circuit current at any instant. Vr is the potential difference across the resistor R. VL is the potential difference across the inductor L. F is the frequency of the applied voltage. Right? Now we'll go to the analysis. The same current I is flowing through the resistor as well as inductor. So we can take current as a reference vector. Current is taken as reference vector. So based on that, the voltage across the resistor VR equal to I into R. V equal to IR. That is in phase with the current, because in the resistor always the current and voltage are in phase. Similarly, the voltage across the inductor VL equal to I into XL. XL is nothing but the reactance, inductive reactance. For inductor, always the leading the current by 90 degree. That is, current is lagging. It means the voltage is leading the current by 90 degree. The resistor always voltage and current are in phase. But in case of inductor, the current is lagging. In other words, the voltage is leading the current by 90 degree. So based on that, we have the phasor diagram is available. So this is the reference vector, current vector. The voltage across the resistor R, VR equal to I into R, that is in phase with the current, so that it is drawn in the horizontal. Then VL, voltage across the inductor I into XL, that is 90 degree leading, right? So that it is drawn in a vertical line, 90 degree leading. This indicates 90 degree leading. So this is the voltage drop across resistor in phase with the current. Voltage drop across the inductor 90 degree leading with the current. So sum of these two, vector sum of these two is nothing but the total voltage V. That is I into Z. Z is nothing but impedance. Impedance is nothing but the sum of resistor and inductance, capacitive reactance. So this is the voltage across resistor. So voltage across inductor. So sum of these two is the total voltage V, that is I into Z, that is Z is nothing but the impedance. So from this diagram, phasor diagram, we can go for the further analysis. So the total voltage V equal to VR plus VL. Voltage drop across resistor and inductor. So V equal to I into R plus J I into XL. What is this J? The J represents the voltage is leading the current by 90 degree. The J represents the 90 degree. The J operator that indicates the leading by 90 degree. So we can take I outside, so that R plus JXL, bring the I in the denominator. So V by I equal to R plus JXL. So this V by I is nothing but the impedance. V by I. So V by I is normally the resistance R. Here we have resistance as well as inductive reactance. So combinedly where it is termed as the impedance. So impedance equal to R plus JXL. So for this circuit, the impedance is R plus JXL. Right? So that is nothing but V by I is taken as a impedance. Then the magnitude of the impedance, Z equal to modulus of Z equal to square root of R square plus XL square. So this is nothing but the impedance, the magnitude of the impedance. Now this is nothing but there are two forms available, rectangular form and the polar form. We'll see that. For that we need an angle. So from this diagram, from this phasor diagram, we can calculate the tan pi. Tan pi equal to opposite side by adjacent side. IXL divided by IR. So II got cancelled, XL by R. So pi equal to tan inverse XL by R. The angle between the voltage drop across resistor and inductor is nothing but tan inverse XL by R. Now we can represent the impedance in two different forms. Z equal to R plus JXL is a rectangular form. Z equal to magnitude of Z and angle pi. This is the polar form. So we can represent the impedance in two different forms, rectangular form and polar form. This Z can be calculated from this formula, pi can be calculated from this formula. Now we'll go for the phase angle between the current and voltage. Now we'll see as per the property of the series circuit, the voltage can be written as V of t equal to VR of t plus VL of t. That is total voltage equal to voltage drop across resistor plus voltage drop across inductor. Right? This is another format. In order to analyze the phase angle between current and voltage, again we are analyzing this voltage. So VR is nothing but R into I of t. V equal to IR. Similarly, the voltage across the inductor is L di by dt. Now we know that I of t is nothing but Im sin omega t. That is for a resistive circuit in phase with the voltage. So I of t equal to Im sin omega t. So di by d of t, differentiate on both the side. Im sin omega t, differentiation of sin omega t is cos omega t into omega. So that is omega Im cos omega t di by dt. That is equal to omega Im sin omega t plus pi by 2. This cos omega to omega t can be written as sin omega t plus pi by 2. Now we got the expression for this di of t divided by dt as well as I of t is available. Now we can substitute these two values in the equation 1. This I of t and di of t can be replaced with this expression. So substitute I of t and di of t in the equation 1, so that V of t equal to Rim sin omega t plus L omega Im sin omega t plus pi by 2. So that is can be written as Rim sin omega t. This omega into Im, omega into L is nothing but XL, inductive reactance. So Im into XL sin omega t plus pi by 2. Now we got the two terms, term 1 and term 2. Now we can analyze these two terms. So the first term is the represent the applied voltage and voltage across the resistor. This term refer the voltage across the resistor. See, the phase angle is omega t only. So the current value also omega t, the voltage also we got omega t. So it is in phase with each other. The voltage across the resistor is in phase with the current. But in case of the second term, voltage across the inductor, we have omega t plus pi by 2. The plus pi by 2 is available. So the second term in the above equation is compared with the equation 1. The phase difference of pi by 2 or 90 degrees available. There is a phase difference of pi by 2 or 90 degree between this voltage and current. So it is obtained by rotating VL vector 90 degree in the vector diagram. So due to that only we are getting the 90 degree. The voltage across resistor and voltage across inductor differ by 90 degree. So that is integrated by this equation. So based on that we can draw the waveform. So this is the voltage. It starts at 0 degree. So the inductive circuit, the current is lagging or voltage is leading. So current starts after pi. Approximately if it is pi by 2 means it is pi by 2 degrees pi. After pi only the current starts. So there is a phase difference of pi between current and voltage, that is current is lagging the voltage. So based on that we can write the waveform V equal to Vm sin omega t. but I equal to Im sin omega t minus pi. This minus pi indicates the current starts after the voltage with an angle of pi. So that is indicated by omega t minus pi. Right? So we got the waveform. Current and voltage is clearly indicated. Current is lagging the voltage by an angle of pi. That is indicated in the equation. Now we'll go for the impedance. So we'll find the impedance for this RL circuit. The impedance is nothing but opposition of circuit to flow of alternating current. It is very similar to resistance. Here we have inductor is available. So inductance, inductive reactance and resistance combined is known as the impedance. So it is denoted by Z. So how it is represented by the triangle is a resistor. That is in phase with the current. 0 degree in phase with the current. This inductive reactance is 90 degree. There is a phase difference of 90 degree between the R and XL. So sum of these two, resistance and inductive drop, is nothing but a impedance. So impedance is the vector sum of resistance plus inductive reactance. So there is a 90 degree phase shift between the resistor and inductive reactance. So from this diagram we can find the value of sin pi. So this is the angle pi. Sin pi is nothing but opposite side by adjacent side. XL divided by Z. We cross multiply this so that XL equal to Z into sin pi. So we can find the XL by using this formula, Z sin pi. Then find the cos pi. Cos pi equal to adjacent side by hypotenuse. R divided by Z. Cross multiply this so that R equal to Z cos pi. So we can find the R value by using this expression. Similarly, XL value from this expression. Now we'll find the impedance. What is the expression for impedance? So impedance is R plus JXL, that we already discussed. R plus JXL is the impedance in a rectangular form. Then modulus Z angle pi is the polar form. How will you find this modulus of Z magnitude? That is square root of R square plus XL square. Then how will you find the angle pi? Tan inverse XL by R. Right? So the impedance can be represented in the two different form. One is rectangular form, another one polar form. In this polar form, this magnitude angle can be calculated from this formula. Now we'll go to the power triangle. So in the power triangle, we have real power at the reference vector, real power. This reactive power, that is quadrature with the real power, that is 90 degree. The sum of real power and reactive power is the apparent power. This apparent power is nothing but vector sum of real power and reactive power. This real power is represented kilowatt. Reactive power represented kilo kVAR. The sum of these two is nothing but apparent power, that is represented kVA. Now we'll see what is real power, reactive power one by one. So this is the triangle, power triangle. So S equal to square root of P square plus Q square. This is the S. That is equal to S square equal to P square plus Q square. So S equal to square root of P square plus Q square. Another form we can represent, S is represented kVA, that is equal to square root of P is represented kilowatt, Q is represented kVAR. So kVA equal to square root of kilowatt square plus kVAR square. So this is a power triangle. Here 90 degrees between real power and reactive power. Now we'll see what is mean by apparent power, what is mean by real power, reactive power one by one. So the real power is nothing but the product of RMS value of voltage and current. Simply V into I. RMS value of voltage. V into I is nothing but a apparent power. The unit is kVA. What is real power? It is the product of applied voltage and active component of the circuit. There is two components available, active and reactive. So if you multiply the active component of current with voltage, that is called a real power or active power. That is nothing but, and another form, the power which is actually consumed or utilized in an AC circuit is called a active power. The given power is consumed or actually utilized by the circuit is called a AC, is called a real power. Another power is available, this is reactive power, that will be dropped in the, that will be reacted in the circuit. That's why it is called a, the power that is consumed for the, for energy conversion, consumed or utilized. So that is represented P equal to VI cos pi. The unit is kilowatt, right? So this is the active component that is actually consumed in the circuit. Then what about the reactive power? It is defined as the product of applied voltage and reactive component of the current. What is reactive component? Power which flow back or forth. That means it moves in the direction in the circuit, react upon itself, react. So the some power is required to activate, that is called a reactive power. The power actually consumed is a active power. The power actually required to activate the circuit is called a reactive power. That's why it is called a reactive component or active component. So Q equal to VI sin pi. The unit is kVAr. So there are three power available: real power and reactive power. Sum of these two is nothing but a apparent power. Now we'll go to the power factor. So power factor is the ratio of real power to apparent power. Real power or true power. What is true power? Real power VI cos pi. What is apparent power? VI. So VI got cancelled, it is cos pi. So power factor is nothing but cos of angle pi. What is this pi? Is the angle between current and voltage. So power factor will give the cos of angle between current and voltage. For getting better result, the angle between current and voltage should be 0. So if it is 0 means the power factor will be 1. Right? So power factor is nothing but cos of angle between current and voltage. It is also defined in another form. Cos pi can be also calculated from the triangle, from the impedance triangle, R divided by Z. Right? It is also called as R divided by Z. So power factor is nothing but cos pi. That is nothing but pi is the angle between supply voltage and current. So in this video we discuss about RL series circuit. Resistor and inductor is connected in series. What is the behavior of the circuit with respect to voltage, current, phase angle, impedance, power factor, power triangle, and other related terms. Thank you. Welcome viewers. In this video we will see the RL series circuit, that is resistor and capacitor is connected in series. Consider this diagram. Resistor and capacitor is connected in series and energized by the AC voltage. We will see what is the behavior of this circuit. What is the current, voltage, what is the impedance, power factor, power we are going to analyze. So here resistor or capacitor are connected in series, energized by the AC voltage. So the VR is the voltage across the resistor, VC is the voltage across the capacitor. So the description is given here. V equal to Vm sin omega t, that is the applied voltage. I is the current of circuit current at any instant. The capital I is the effective value of current. VR is the potential across resistor R. Vc is the potential drop across capacitor. F is the frequency. Now in this circuit, series circuit, the same current I is flowing through the resistor as well as capacitor. So the current is taken as a reference vector. Now we are going to draw the vector diagram. In that we are taking current as a reference vector because the same current is flowing through capacitor as well as resistor. So based on that, this voltage across the resistor VR equal to IR in phase with the current. So the voltage across the resistor is I into R. So the resistor we know very well, it is always in phase with the current. The voltage across the capacitor VC equal to I into XC. This XC is nothing but capacitive reactance. So the capacitor always the current is leading, that is otherwise the voltage is lagging the current by 90 degree. Current is leading in capacitive circuit, and other words the voltage is lagging the current by 90 degree. So the voltage is now lagging the current. So based on that, we have vector diagram is available, phasor diagram is available. So this is the voltage drop across the resistor. VR equal to IR. This is a voltage drop across the capacitor. So that is lagging the current. The capacitor across the voltage is lagging the current, so it is drawn downwards. So it is lagging the applied voltage, lagging the current. Vc equal to I into Xc. So sum of these two is the total potential. V is I into Z. The Z is nothing but impedance of the circuit. The vector sum of resistance and capacitive reactance is nothing but a impedance. So here voltage is lagging the current, so it is given in the downward direction. In case of RL circuit, the voltage is leading the current. That is, current is lagging, voltage is leading. So in that case, the inductive reactance will be drawn in the upward direction. So leading. Now it is lagging. Voltage is lagging. So based on that, we'll go for the total voltage. V equal to VR plus Vc. That is IR minus JIXC. So this minus sign indicates it is lagging the voltage. If it is plus J means leading the voltage, leading the current. So the minus J represents lagging the current. That's why it is given minus. So take I outside, so that R minus JXC. Bring the I in the denominator. So V divided by I equal to R minus JXC. So V divided by I is nothing but impedance. That is equal to R minus JXC. So in the magnitude, we will taking modulus, it is nothing but square root of R square plus Xc square. So this is nothing but a impedance. So impedance of this RC series circuit is square root of R square plus Xc square. So this is a rectangular form. We can write in a polar form also, another form is available. So from this phasor diagram, we can find the value tan pi. Tan pi is nothing but adjacent side by hypotenuse. IXC divided by IR. IXC divided by IR. I get cancelled, so XC divided by R. So from that, pi equal to tan inverse XC by R. So the angle, the phase angle pi is nothing but tan inverse XC by R. While writing polar form, we can use this angle pi. Right? Now this is the rectangular form. Polar form, we can use this angle. Now we'll go to the phase difference between current and voltage. So because of series circuit, the applied voltage can be written as voltage drop across resistor plus voltage drop across capacitor. This is one more analysis in order to get the angle between applied voltage and current. So VR is nothing but R into I of t. V equal to IR. So R into I of t. The voltage drop across the capacitor is 1 by C integral I dt. So formula is available. What is I of t? I of t is nothing but Im sin omega t. So R into Im sin omega t plus 1 by C integral I of t is Im sin omega t into dt. So that is R into Im sin omega t plus this Im is taken outside, Im by divided by C. The integral sin omega t is minus cos omega t divided by omega. So that what will happen here, R Im sin omega t plus Im by omega C. This omega is taken outside, so omega into C minus cos omega t. So this minus cos omega t can be written as sin omega t minus pi by 2. Right? Minus of cos omega t can be written as sin of omega t minus pi by 2. Now we have two terms available. Now we can analyze these two terms so that we are able to find the angle between current and voltage. So the first term R Im sin omega t is the voltage drop across the resistor. That is in phase with the current. There is no angle here. Only omega t is available. That means voltage drop across the resistor is in phase with the current. The second term refers the voltage drop across the capacitor. See here minus pi by 2 is available. That is current is leading or voltage is lagging the current by 90 degree. So this voltage is lagging the current by 90 degree. That's why we got the in the phasor diagram the voltage drop of the capacitor is drawn downwards. So from this two term we are easily identify that voltage drop across the resistor in phase with the current, voltage drop across the capacitor is leading 90 degree or voltage is lagging the current by 90 degree. There is a phase difference of 90 degree. The current is leading or voltage is lagging. So based on that we can draw the waveform. See, the voltage is starts at 0 degree. We know that current is leading. So before starting voltage, the current start here itself. The current starts earlier. In case of inductor, the current start later. Here the current start earlier. So there is a phase difference of pi between current and voltage. That is, current is leading or voltage is lagging. Here current is leading. So based on that we can write V equal to Vm sin omega t. It starts at 0 degree. But I equal to Im sin omega t plus pi, because it starts earlier, so it is added. If it is later, minus pi. If it is earlier means in case of capacitor the current starts earlier. So sin omega t plus pi. So from that we can easily add the current I leads the applied voltage V by an angle of pi. There is a phase difference of pi, that is current is leading. Now we'll go to the impedance. So the impedance is nothing but the opposition of circuit flow of alternating current. It's like a resistance. Impedance is very similar to resistance. Here we have resistance as well as capacitive reactance, combinedly known as impedance. That is nothing but opposing the flow of alternating current. It is denoted by Z. So the impedance triangle is available. This is the resistance R, that is in phase with the current. This is capacitive reactance Xc. That is the voltage is lagging the current, so that is gone downwards. The voltage is lagging. That is current is leading but voltage is lagging. The sum of these two R and Xc is nothing but the impedance. So this is the phase angle between the R and Z pi. So from that, based on that we can write the impedance Z equal to R minus jXc. This minus represent it is downwards, lagging, voltage is lagging. So that can be written as Z modulus of Z into pi, angle pi. It's a polar form. How will you find modulus of Z? Square root of R square plus Xc square. Then how will you find the pi, the angle, phase angle? So from this triangle we can find sin pi. Sin pi equal to opposite side by hypotenuse. Xc divided by R. Xc divided by Z. Opposite side by hypotenuse. Xc divided by Z. From that cross multiply this. So Xc equal to Z into sin pi. Similarly find the value of cos pi. Adjacent side by hypotenuse. Adjacent side R by Z. So cross multiply this so that R equal to Z cos pi. Similarly find the tan pi. Opposite side by adjacent side. Opposite side by adjacent side. Xc divided by R. So that pi equal to tan inverse Xc divided by R. So pi equal to minus tan inverse Xc by R, because it is lagging. So from this the pi can be calculated from this value. So impedance given in rectangular form as well as polar form. This is a polar form. Now we'll go to the power triangle. Based on this we can analyze the power triangle. So the power triangle we have three different power available. It's a real power are called active power, actively utilized in the circuit. Its term is P, the unit is kilowatt. Another one reactive power, not consumed but it will react with the circuit. Some power required to initiate the circuit is called a reactive power. This term is Q, kVAR. Why it is downward? Because the voltage is lagging. Current is leading but the voltage is lagging, so that it is drawn downwards. The sum of these two, real power and reactive power, is the apparent power, total power. kVA. kVA. So S equal to square root of P square plus Q square. That is kVA equal to square root of kilowatt square plus kVAR square. Right? So the real power, reactive power and apparent power. Now we'll see the definition. Apparent power is nothing but it is defined as the RMS value of voltage and current. S equal to V into I. The unit is kVA. Apparent power means RMS value of voltage and current. Now we'll go to the real power. It is defined as the product of applied voltage and active component of the circuit. Real power or active power means active component. What is active component? The power which is actually consumed or utilized in the circuit. For energy conversion, actually it is consumed. The power is actually consumed. Some of the power is not consumed. It is dropped in the circuit. That is called a reactive power. The power fully utilized for conversion is called a active power. So that is represented P equal to VI cos pi. The unit is kilowatt. Right? The power which is actually consumed or utilized is called a active power. Then what about the reactive power? It is the product of applied voltage and reactive component of the current. Reactive component. What is reactive component? The power which flows back or forth. That means it moves in both the direction in the circuit or react upon itself. The power is not converted. It is reacted. It is dropped in the circuit itself in order to initiate and other purpose. That is called a reactive power. So Q equal to VI sin pi. The unit is kVAR. Right? Now we discuss about the apparent power, real power and reactive power. Based on that, we'll go to the power factor. Power factor is the ratio of real power to apparent power. Real power or true power. What is true power? Real power VI cos pi. Apparent power VI. VI got cancelled. It is cos pi. So power factor is nothing but cos of angle between pi. The pi is nothing but the angle between current and voltage. So the power factor defines the cos of angle between current and voltage. So current and voltage, the angle between current and voltage is 0 means we'll get the better power factor 1. Cos 0, the angle is 0, cos 0 means 1. And another formula also available, the cos pi from the triangle, impedance triangle, we can find R divided by Z. Cos pi also calculated from the impedance triangle, that is R divided by Z. So pi is the angle between supply voltage and current. So in this video we discuss about the RC series circuit. Resistor and capacitor is connected in series. What is the behavior of the circuit? Thank you. Welcome viewers. In this video we will see the RLC series circuit. Consider this diagram. Resistor, inductor and capacitor are connected in series. It is energized by the supply AC voltage. Now we are going to analyze what is the behavior of the circuit. What is the voltage, phase angle between current and voltage, power factor, all these things we are going to analyze. So the V equal to Vm sin omega t is the applied voltage. I is the RMS value of the current. VR is the voltage across the resistor R. VL is the voltage across inductor. VC voltage across the capacitor. So the current I, same current I is flowing through all three elements, resistor, inductor and capacitor. So we can take current as a reference vector. So based on that, the VR, voltage drop across resistor, equal to I into R. Voltage drop across inductor is I into XL. Voltage drop across capacitor is I into XC. So in this circuit we have inductor as well as capacitor. The inductor is available means the current is lagging. If capacitor is available means the current is leading. The analysis of RL circuit, RC circuit available in the previous video. Link is available in the description box. You can view that. So in this we have both inductor and capacitor. So based on the value of inductor and capacitor, the current may be lagging or leading. Based on that we have three different cases are available. So first one is XL equal to XC. In the case 1, this capacitive reactance equal to inductive reactance. Both are equal. We assume that there are 3 different cases. Case 1 is both are equal. If both are equal, it is act as a pure resistance. If XL equal to XC, the circuit is like a resistance because capacitive reactance is cancelled by the inductive reactance. That is leading lagging is cancelled. So that it is act as only resistance. If it is resistant mean current is in phase with the applied voltage and power factor is also unity. If XL equal to XC, both the effects are got cancelled. The current will be in phase with the voltage and power factor become 1. So based on that, the phasor diagram is available. The current is available here. This is the voltage across the inductor. This is the voltage across the capacitor. Both are equal. Both got cancelled. So that only the voltage is available. VL equal to VC, XL equal to XC. So that voltage and current are in phase with each other. It is like a resistive circuit, simply a resistive circuit. So there is no phase angle, so the power factor also 1. Now we'll go to the second case. In this, the XL is greater than XC. Capacitive reactance is lesser. Inductive reactance is more. Right? Here, the capacitive reactance is less and inductive reactance is more. In that case, it will act as a RL circuit. Because of inductive reactance, more inductive reactance, it acts as a RL circuit. If RL circuit, inductive circuit means current lagging the applied voltage. Current is lagging. So the power factor is also lagging. So in the based on our condition assumption, inductive reactance is more than the capacitive reactance, so that it acts as a RL circuit. If it is RL circuit means the current is lagging the lag begins the voltage, so the power factor is also lagging. So based on that, the phasor diagram is available. The current is taken as the reference vector. The voltage across the resistor is in phase with the current. Right? This VR is in phase with the current. This voltage across the inductor is leading. That is, current is lagging means the voltage is leading. Similarly, the voltage across the capacitor, the current is leading means voltage is lagging. In case of capacitor, current leads but the voltage is lagging. See this magnitude, this VC is lesser, VL is more. VL is greater than this VC. Right? So the difference between these two, VL minus VC, is available here. In that VL, if you subtract VC, the remaining voltage is available. So the vector sum of this VL minus VC and VR is nothing but the total voltage. Because voltage is leading, we are getting the angle also in a leading. Pi in a positive value. So V is the vector sum of this VR and VL minus VC the whole square. So here the current is taken as reference. The voltage across the resistor in phase with the current. The voltage across the inductor leads the voltage. The voltage across the capacitor lagging the voltage. So the difference between these two is nothing but VL minus VC. Because VC is lesser, VL is more. The sum of these two voltages is nothing but the total voltage V. So that is given here. So based on that, the waveform is available. This is a voltage. Starts at 0 degree. Here RL circuit, so current is lagging. So current starts after some time. That is a pi angle. After pi angle only the current starts. So the current lags the applied voltage by V. So there is a lagging between current and voltage. That is, current is lagging by angle of pi. So the current waveform, this voltage waveform. So based on that, we'll have the impedance diagram. So this is the resistance in phase. This capacitive reactance is lesser, inductive reactance is more. So the voltage is leading. That is, current is lagging means voltage is leading. So that we are getting in a upward direction. So this is nothing but the difference between XL minus XC. The sum of these two is nothing but the impedance. R plus X, JX. J represents 90 degree. right? This X is nothing but XL minus XC, and pi is positive because voltage is leading, right? So the reactance here is nothing but difference between inductive reactance and capacitive reactance, XL minus XC. So from this diagram we can easily write that V square equal to VR square plus VL minus VC the whole square from the phasor diagram. From the previous phasor diagram we can write this equation from this diagram. V square equal to VR square plus VL minus VC the whole square. So that we can go for further analysis. So VR is nothing but IR, I into R. VL is IXL, VC is IXC. So the I is available everywhere, so take outside. I square equal to R square plus XL minus XC the whole square. This is V square. We take square root on both sides, so that V equal to I square root of R square plus XL minus XC the whole square. So this term is nothing but a impedance Z. That is V by I, Z equal to V by, bring this I in the denominator, so Z equal to V by I. So the impedance of this case XL greater than XC means square root of R square plus XL minus XC the whole square. This is the impedance for the second case. Now we'll go to the third case. In this, capacitive reactance is more than the inductive reactance. XL is greater than XC. So this circuit will act as a RC circuit. Capacitor, resistor and capacitor circuit. Capacitor circuit means current is leading the voltage. Current is leading the applied voltage, so the power factor also leading. Right? So due to more capacitive reactance, the circuit acts as a RC circuit. So the current is leads the applied voltage and power factor is 0. Power factor is leading. So based on that we have phasor diagram and waveform. So this is a reference vector current. The voltage across resistor is in phase with the current. So this is the voltage across the inductor, lesser value. This is the voltage drop across the capacitor, more value. Right? XC is more than VC. So the difference between these two, this is lesser, difference between these two is VC minus VL. Because current is leading but the voltage is lagging here. Voltage lags, current leads. So that it is drawn in downward direction. So vector sum of these two, VR square plus VC minus VL square is nothing but total voltage V. So the angle also negative, the voltage, the resultant voltage also available in the negative direction, because capacitor circuit current is leading but the voltage is lagging. Voltage is lagging. So this is the resultant voltage. Now we'll see the waveform. This is the voltage waveform. Starts at 0 degree. Current starts leading, right? So current start earlier. Before starting the voltage, current start earlier with an phase angle of pi. So there is a phase difference between current and voltage is pi, that is leading. Current starts earlier. In previous case RL, the current start later. Here current start earlier. So there is a phase difference of pi. Now we'll go to the impedance triangle. So this is the resistance, because of voltage is lagging, so that it is drawn in downward. This is nothing but XC minus XL. Because XC is more, XL is less, so that XC minus XL. Vector sum of these two is impedance, R plus JX. So the X is nothing but XC minus XL. So the pi is also negative. So now we discuss the RLC series circuit. Here the three cases available. XL is equal to XC. Both inductive capacitive reactance are equal. In the second case, capacitive reactance is lesser, inductive reactance is more. That acts as RL circuit. In third case, capacitive reactance is more and inductive reactance is less, that acts as RC circuit. We analyze the phasor diagram, waveform as well as impedance triangle for all three cases. Thank you. Welcome viewers. In this video, we will see the solved problem, the part 1 for the RL series circuit. When resistor and inductor is connected in series, energized by the AC supply. For that circuit, we'll see the solved problem. First, we'll see the problem 1. A series RL circuit have this voltage and current equation is given. I of t equal to 5 sine 314t plus 2 pi by 3. Similarly, voltage V of t equal to 20 sine 314t plus 5 pi by 3. The equation for current and voltage is given. They determine the first one, impedance of the circuit, the value of R and L and power factor, then average power of the circuit. So we need to find these parameters. So based on the given data, the current is given as, the current equation is 5 sine 314t plus 2 pi by 3. So this 2 pi by 3 is nothing but the angle, phase angle of current, angle between current and voltage, that is given 2 pi by 3. So that is 2 into pi is 180, 180 by 3. So 2 into 180 by 3 is 120 degree. So the phase angle of current is 120 degree. Similarly, the voltage V of t equal to 20 sine 314t plus 5 pi by 3. So the phase angle of voltage is theta V is 5 pi by 3. So 5 into pi is 180 divided by 3. So 5 into 180 by 3, it is 150 degree. So we calculated the phase angle of current as well as voltage from the given equation. So this is nothing but a phase angle of voltage. This is a phase angle of current we calculated. So the phase angle between current and voltage can be calculated from this. The theta equal to theta V, the difference between theta V and theta I. It's not a subtraction, it's a difference. Right? Difference between the phase angle of voltage and current will give the phase angle between voltage and current. So 150 difference with 120 is 30 degree. So the phase angle between current and voltage is 30 degree. So from this we can find the power factor, because power factor is cos of theta. Theta is nothing but angle between current and voltage. So we know the current and voltage, angle between current and voltage. So cos theta is the power factor, that is cos 30, that is 0.866 lagging, because here we have the inductor circuit. So the inductor circuit always current lags the voltage, so that it is given lagging, right? So from the voltage equation we calculated the phase angle of current, then phase angle of voltage. From that we calculated phase angle between current and voltage. By using the angle we calculated the power factor. Now we'll go to the next parameter, impedance of the circuit. Impedance can be calculated Vm by Im, R equal to V by I. Similarly, Z equal to Vm by Im. So 25 divided by 5 is 4 ohm. This Vm Im is already available from the equation. So this is nothing but Im. This is Vm. I equal to Im sin. Similarly, V equal to Vm. So these two are the maximum value of current and voltage. By using that we calculated Z equal to 4 ohm. Now we can calculate the R and L value. So one more formula is available for power factor, cos pi equal to R divided by Z. From the Phasor diagram this formula is available, cross multiply this, so that R equal to Z cos pi. The Z now we calculated 4 ohm. The cos pi, the power factor also we calculated 0.866. So by multiplying this, what we got, R equal to 3.46 ohm. So the R value is calculated. Now we'll calculate the L value. For that we'll find the impedance. The impedance general formula is available. The magnitude of impedance Z equal to square root of R square plus XL square. So general formula. Now square on both the sides. So Z square equal to R square plus XL square. Bring this XL in the left hand side. So minus XL square equal to R square minus Z square. Bring the Z square in the right hand side. Now multiply with negative, so that XL square equal to Z square minus R square. These two are interchanged. So XL equal to, by taking the square root of Z square minus R square. Now Z value is, we know that Z value is 4 ohm. R value is we calculated 3.46. So by simplifying this, what we got, 2 ohm, right? So this is nothing but a Z. This the value is 4 ampere. This is R. This value is R. So now we got the inductive reactance 2 ohm. Inductive reactance we calculated as 2 ohm. From that we can calculate the inductor value. XL equal to 2 ohm we calculated, but XL is nothing but omega into L. The general formula is available. So XL equal to 2, omega is 314. From the voltage and current equation, the omega we identified as 314 into L. So L we need to find, so we bring the 314 in the denominator. So 2 divided by 314 is nothing but inductor. By simplifying this, what we got? 6.37 into 10 to the power minus 3 Henry. So now we calculated inductor value also. So the one more parameter we need to find average power. Average power is VI cos pi. VI is nothing but Vm by root 2. I is nothing but Im by root 2. Right? Vm, Im value is available. These values are not given. So we calculated V is nothing but Vm by root 2. I is nothing but Im by root 2. Then cos pi power factor is 0.866. So by simplifying, what we got? 43.3 watts. The average power is 43.3 watts. So now we calculated all the parameters. Now we'll go to the second problem. The second problem, a coil having resistance of 6 ohm and inductance of 0.03 Henry connected across 100 voltage 50 Hz supply. Right? The resistor of 6 ohm and inductor of 0.03 Henry is connected across the 100 ohm 100 voltage 50 Hz supply. We need to calculate the current, phase angle between current and voltage, power factor and power. We need to find these parameters. So by analyzing the given data is the R is available 6 ohm, L is 0.03 Henry, voltage is 100 voltage, the frequency is 50 Hz. First we will find the XL. In order to find the current, we will find XL. The inductive reactance is 2 pi F into L. Inductive reactance is XL equal to 2 pi FL. So 2 into pi into F is 50 and L is 0.03. These data are available. So by simplifying, we got 9.42 ohm. The XL is calculated. From that we can calculate the impedance. Impedance is nothing but square root of R square plus XL square. The R value is given 6 ohm and XL is we calculated 9.42. So square root of 6 square plus 9.42 square, that is equal to 11.17 ohm. So now we calculated impedance also. From that we can easily calculate the current and other parameters. The current I is V divided by Z. So V is 100 voltage. The Z we calculated 11.17. So by simplifying, what we got? 8.95 amperes. The current is calculated. Now we can calculate the phase angle between voltage and current. The formula is available. Pi equal to tan inverse XL by R. So the XL is nothing but 11.1. The XL is nothing but a 9.42 and R value is 6 ohm. So tan inverse 9.42 divided by 6, we got 57.5 degree. The angle between current and voltage is 57.5 degree. It's lagging. Why it is lagging? It is a RL circuit. Inductor is available. Inductor, in the inductor the current is always lagging the voltage. So that it is given the lagging. Now we'll find the power factor. Power factor is cos pi. The pi value we calculated 57.5 degree. So cos 57.5 degree is 0.537 lagging. So here also lagging due to inductance. Now we calculate the power, average power. Average power is VI cos pi. The voltage is given 100. The current we calculated 8.95 and cos pi power factor just now calculated 0.537. So by simplifying this, we got 480.6 watts. The power factor as well as average power is calculated. So in this video we discuss about the solved problem based on the RL circuit, resistor and inductor connected in a series. We solved the two different problems. Thank you. Welcome viewers. In this video we will see the solved problem based on the RL series circuit, resistor and inductor connected in series. This is a part 2. Part 1 already available, a separate video. Link is available in the description box. First we will see the problem 1. A 10 ohm resistor and 20 millihenry inductor are connected in series across a 250 voltage 60 Hz supply. 10 ohm resistor and 20 millihenry inductor are connected in series, that is across a 250 volt 60 Hz supply. We need to find the impedance of the circuit, voltage across the resistor, voltage across the inductor, apparent power, active power and reactive power. So based on the given data we have R value is available. R is 10 ohm. Inductor L equal to 20 millihenry, that is 20 into 10 to the power minus 3 Henry. The voltage is 250 voltage, the frequency is 60 Hz. First we will find the inductive reactance, then we will go to the other parameters. The inductive reactance XL equal to 2 pi F into L. The formula is available. So 2 into pi into F is 60 and L is 20 into 10 to the power minus 3. By simplifying this we got 7.54 ohm. The inductive reactance is 7.54. So based on this value we can go for the parameter. First we will find the impedance of the circuit. Impedance, the magnitude of Z equal to square root of R square plus XL square. The formula is there. So R square is 10 square, XL is 7.54 square. So by simplifying this we got 12.5 ohm. The impedance of the circuit is 12.5 ohm. Then we will find the voltage across resistor and inductor. Before finding, first we will find the current flowing through the circuit. Because of series circuit, same current is flowing through the resistor as well as inductor. So I equal to V divided by Z, voltage divided by impedance. The voltage is 250, impedance is 12.5. So by simplifying this we got 20 amperes. So current flowing through the circuit is 20 amperes. Then we will find the voltage across the resistor, VR, equal to I into R. That is equal to 20 into 10. I is 20 ampere, R value is 10. So 20 into 10, 200 voltage. Voltage across the resistor is 200. Similarly, the voltage across the inductor, VL, equal to I into XL. I into inductive reactance. The I value is 20. The inductive reactance is 7.54. We already calculated. By simplifying this, we got 150.8 voltage. So the voltage across the inductor is 150.8 voltage. Now we will go to the active power. Active power S is nothing but V into I, voltage into current. Voltage is 250, current is 20. So 250 into 20, 5000 VA. The unit for active power is voltage ampere. Then we will find the active power. The active power is VI cos pi. This is nothing but a pi is a power factor, cos pi. So we need a value of cos pi. So first we will find cos pi value. Cos pi equal to R divided by Z. From the Phasor diagram this relation is available. Cos pi equal to R divided by Z. So 10 divided by 12.5, that is equal to 0.8. Is lagging. Because of inductive circuit, the current is lagging in the inductive circuit. Current is lagging the voltage. So that it is mentioned as lagging. So now cos pi is calculated so that we can find the active power, that is equal to VI cos pi. V is 250, I is 20 ampere, cos pi is 0.8. So by simplifying this we got 4000 watts. The unit for active power is watts, 4000 watts. Now we will find the reactive power. For reactive power what we need is a sin pi. VI sin pi is the reactive power. So we will find sin pi. Sin pi can be calculated from this relation. Sin pi equal to square root of 1 minus cos square pi. That is sin square theta plus cos square theta equal to 1. From that we framed this equation. Right, now we'll substitute 1 minus cos pi value is 0.8. So 0.8 square. By simplifying we got 0.6. The sin pi value is 0.6. So the reactive power V into I into sin pi, V is 250, I is 20, sin pi is 0.6. So that by simplifying we got 3000. 3000 VAR. The unit for reactive power is VAR. For apparent power the unit is VA. Active power the unit is watts. The reactive power the unit is VAR. Now we calculated all the parameters. Now we'll go to the second problem. A coil when connected 200 voltage and 50 Hz supply that takes a current of 10 ampere and dissipated 1200 watts. So one coil is connected with 200 voltage and 50 Hz supply. It will takes the 10 ampere current and dissipate the 1200 watts. In this problem we need to find the value of resistor and inductor of the circuit. We need to find the resistor value and inductor value. So the given data is voltage is available 200 voltage, frequency is 50 Hz. The current taken is 10 ampere because both are connected in series, same current is flowing, and power dissipated is 1200 watts. So based on that first we will find the resistor value. So power equal to I square R, the formula is available. Power equal to V into I, one formula, I square R one formula, V square by R another formula. Three different formula available. Here we can use this formula because current is available, power is available. So we can use P equal to I square R. We need R value. So bring the I square in the denominator. So P divided by I square equal to R. So the P is 1200, I is 10, 10 square. So by simplifying this we got 12 ohm. The resistor value is 12 ohm. Now we'll go to the inductor value. Before finding inductor value, first we will find the impedance. Impedance, the magnitude of Z equal to magnitude of V divided by magnitude of I. So that is equal to 200 by 10, that is 20 ohm. The impedance of the circuit is 20 ohm. Next we will find the inductive reactance. How will you find? The formula is available. Z square equal to R square plus XL square based on the impedance triangle. We need XL square. So bring this R square this side. So XL square equal to Z square minus R square. So XL, take square root on both sides. So XL equal to square root of Z square minus R square. So Z is we already calculated 20 square minus R value is 12 ohm, 12 square. So by simplifying we got 16 ohm. The inductive reactance is 60 ohm. This inductive reactance another formula is available. Inductive reactance XL is nothing but omega into L. Omega is nothing but angular velocity 2 pi into 2 pi f into L. So the XL value we calculated 16. So 2 into pi into frequency is 50 Hz into L. So this L we need to calculate. So bring this term in the denominator. So 16 divided by 2 into pi into 50. By simplifying this we got L equal to 50.93 millihenry. Milli means 10 to the power minus 3. So now we calculate a resistance value as well as inductance value. So in this video we discuss about the solved problem based on the RC series circuit. Part 2. Part 1 also available. Thank you. Welcome viewers. In this video we will see the solved problem based on the RC series circuit. Resistor and capacitor is connected in series. For that we are going to see the solved problems. First we will go to the problem 1. A capacitor having a capacitance of 10 microfarad is connected in series with a resistance of 120 ohm across a 100 voltage 50 Hz supply. This resistor and inductor, this resistor and capacitor are connected in series across this supply. We need to find the current, power, phase difference between current and voltage and supply voltage. We need to find this parameter. So the given data is capacitor equal to 10 microfarad, that is 10 into 10 to the power minus 6 farad. Micro means 10 to the power minus 6. The R resistor value is 120. The voltage, supply voltage is 100, the frequency is 50 Hz. So before going to find the value, first we will find the inductive reactance, capacitive reactance, Xc. Xc equal to 1 divided by 2 pi Fc. So substitute the value 1 divided by 2 pi, the frequency is 50, the capacitor value is 10 into 10 to the power minus 6. So by simplifying this, we got 318 ohm. The capacitive reactance is 318 ohm. Now we can find the impedance of the circuit. Impedance is square root of R square plus Xc square. So the R value is 120, Xc value is 318. Just now we calculated. So by simplifying this, we got 340 ohm. So the impedance of the circuit is calculated. So by using that, we can calculate the current. Current I equal to V divided by Z. So V is 100 voltage. The Z is calculated as 340. So 100 by 340, by simplifying this, we got 0.294 ampere. So current flowing through the circuit is 0.294 ampere. Now we'll go to the phase difference. So phase difference, the formula is available. Pi equal to tan inverse Xc by R. From the phasor diagram, this formula is derived. So Xc value is 318. We calculated 318 divided by R value is 120. So tan inverse 318 by 120 is, we got 69.3 angle degree. 69.3 degree is given leading because of capacitive circuit. Capacitor is available. So in the capacitor, the current is always leading the applied voltage. So that this angle is leading. So from this pi value, we can easily calculate the power factor. So the angle between the current and voltage is 69.3 with a leading. So power factor is nothing but cos pi. Cos pi equal to cos of pi value. Pi value is 69.3. So cos of 69.3 is nothing but 0.353. Is also leading because of capacitor. Current is lead in the capacitor. Now we'll go to the power. This is average power. P equal to Vi cos pi. V is 100 voltage. The current is 0.294. We calculated. The cos pi value is 3.53. So by simplifying that, we can get the value of P. P equal to 1010.38 watts. The average power is calculated as 10.38. So now we calculated all the values: current, phase difference, power factor and power. Now we'll go to the second problem. The resistor R in series with a capacitor C is connected to a 50 Hz 240 voltage supply. Resistor and capacitor is connected in series, that is connected across the 50 Hz 240 voltage supply. The question is, find the value of capacitor so that resistor R absorbs 300 watts at 100 voltage. We need to find the capacitor value. The other values are given as the resistor is absorbing 300 watts at 100 voltage. And also we need to find maximum charge as well as maximum stored energy in the capacitor. So this is the question we need to find. So the data available is V equal to 240 voltage, frequency is 50 Hz. The power absorbed by the resistor is 300 watts at a voltage of 100 voltage. So first we will find the parameter one by one. First we will find the voltage. Based on the series circuit, total voltage equal to sector sum of voltage across resistor plus voltage across capacitor. So V square equal to VR square plus VC square. Now we need a VC square. So this VR, bring this VR that side. So that VC square equal to V square minus VR square. Now take the square root on both sides. So that VC equal to square root of V square minus VR square. So V square is given 240. Total voltage is 240. The voltage across the resistor is 100 voltage. So by simplifying this, we got 218.2 voltage. 218.2 voltage. Now we calculated the voltage across the capacitor. Now we'll go to the power, because power is given. Power absorbed by the resistor is 300 watts. Based on that, the power equal to VR into I. Power absorbed by the resistor equal to voltage across the resistor into I. Power absorbed by the resistor is 300. The voltage across the resistor is 100 into I. So bring this 100 in the denominator, so that I equal to 300 by 100, it is 3 ampere. So the current is 3 ampere. Because of series circuit, the same 3 ampere is flowing through the capacitor as well as the resistor. So from that we can find the XC value, capacitive reactance. XC equal to VC by I. VC is 21.82. That is voltage across the capacitor. Just now we calculated. The current is 3 ampere. So by simplifying, we got 72.73 ohm. Capacitive reactance is 72.73 ohm. This capacitive reactance, the other formula is available. The XC is nothing but 1 divided by 2 pi FC. That is equal to 72.3. So we need this C value. Bring this C in the numerator, 72 point in the denominator. So that C equal to 1 divided by 2 into pi into the frequency 50 hertz, and this XC value is 72.73. So by simplifying this, what we got, 43.77 into 10 to the power minus 6 farad. That can be written as 43.77 microfarad. 10 to the power minus 6 means microfarad. So now we calculated the capacitor value. Now we'll go to maximum charge and maximum energy stored. So the maximum charge QM is nothing but capacitance multiplied by maximum VC. This capacitance value already we calculated, 43.77 into 10 to the power minus 6. So we need a value of VC, maximum VC. So we will find maximum VC first. Maximum VC equal to root 2 into RMS value of VC. So that is equal to root 2 into RMS value of VC is 218.2. That also we calculated. So by simplifying that, maximum VC equal to 308.6 voltage. Now we calculated the maximum VC. Now substitute this value here. So by simplifying this, we got maximum charge is 0.0135 coulomb. Now we will go to the energy stored. The energy stored is half C into maximum VC square, half CV square, that is maximum VC square, maximum energy, so that here we are using maximum voltage. So half into C value is 43.77 into 10 to the power minus 6. The maximum VC, just now we calculated 308.6 maximum VC square. So by simplifying, we got 2.08 joule. So we calculated all the parameters. So in this video, we discuss about the solved problem based on the RC circuit, part 1. Thank you. Welcome viewers. In this video, we will see the solved problem based on the RC series circuit. Resistor and capacitor is connected in series. Based on that, we will see the problem. So part 2. Part 1 already available in separate video. The link is available in the description box. Now we'll go to the first problem. A capacitor and resistor are connected in series to a AC supply of voltage 60 voltage 50 hertz. The current is 2 ampere. The power dissipated in the resistor is 80 watts. The capacitor and resistor connected in series with this supply voltage. The current is 2 ampere, power dissipated 80 watts. We need to find the impedance of the circuit, the value of resistance, capacitance and power factor. We need to find this parameter. So the given data is voltage is 60 volt, frequency is 50 hertz, current is 2 ampere and power dissipated in the resistor is 80 watts. First we will find the impedance. Impedance Z equal to V by I. Magnitude of Z equal to magnitude of V divided by magnitude of I. So 60 divided by 2. Voltage and current is available. 60 divided by 2, 30 ohm. Now one more data, we will find the resistor value. The power is given. Power dissipated in the resistor is given. So power P equal to I square R. So from that R equal to P divided by I square. The P is given 80 watts and I is 2 ampere. So 80 divided by 2 square, 80 divided by 4 is 20 ohm. So the resistor value is 20 ohm. Now we'll find the capacitor's value. So first we will find the impedance. Z square equal to R square plus Xc square. From the impedance triangle we can found this relation. So what we need is Xc square. So Xc square equal to Z square minus R square. By taking square root on both the side, Xc equal to square root of Z square minus R square. Now we will substitute the value. The Z is 30 ohm we calculated, R is 20 ohm, that also we calculated. So by simplifying this we got 22.36 ohm. Now we got the capacitive reactance. For capacitive reactance one more formula is there, Xc equal to 1 divided by 2 pi Fc. So from that we can rearrange this X and Xc. So that C equal to 1 divided by 2 pi into Xc. So because we need to find the capacitor value. So C equal to 1 divided by 2 into pi into the frequency is 50 Hz. The Xc we calculated as 22.36. So by simplifying this we got 142 into 10 to the power minus 6 farad. This minus 6 can be written as microfarad. So C equal to 142 microfarad. Now we got the capacitance value also. Now we will find the power factor. Power factor, the formula available R by Z from the power triangle. From the impedance triangle we can easily find cos phi equal to R by Z. The R is 20 and Z is 30, we already calculated. So 20 divided by 30, 0.67. Leading. Because of capacitive circuit is given leading. In capacitive circuit the current is lead the applied voltage. So that this power factor is 0.67 leading. Now we calculated all the parameters. We will go to the second problem. A metal filament lamp rated at 750 watts 100 voltage is connected to series with a capacitor across a 230 volt 60 Hz supply. Calculate the capacitance required and power factor. We need to find what is the capacitor value and also what is the power factor. So the lamp is 750 watts with a voltage is 100 voltage. The supply voltage is 230 voltage 60 Hz. Now we will find the capacitor value. So from the given data first we will find the power. Power P equal to I square R or VR into I. So the power value is given. So from that I equal to P divided by VR. Power dissipated in the lamp is 750 watts. So based on that we can use this formula P equal to VR into I. So that I equal to P divided by VR. So the power dissipated is 750. The voltage across the resistor is 100. So these two are given 750 and 100. So that 750 divided by 100 is 7.5 ampere. So current flowing through the circuit is 7.5 ampere. Because of series circuit same current is flowing through resistor as well as capacitor. So from the power dissipated and voltage across the resistor we calculated the current value. So this is the series circuit, so that total voltage equal to voltage across resistor plus voltage across the capacitor, that is V square equal to VR square plus VC square. So we need VC square, that is equal to V square minus VR square. This it is interchanged. By taking square root, VC equal to square root of V square minus VR square. The V is nothing but 230 voltage. The supply voltage is 230 voltage. The voltage across the resistor is 100 voltage, that is given. So by simplifying that we got VC equal to 207 voltage. It's not a watt, it's a voltage. 207 voltage. Now we calculated the voltage across the capacitor also. Now we'll go to the next step. Now we'll find the capacitive reactance Xc equal to Vc by I. The one formula is available, Xc equal to Vc by I, R equal to V by I, like that. So Vc, voltage across the capacitor, is 207. Just now we calculated. The current is 7.5 ampere. So 207 divided by 7.5, 27.6 ohm. So the capacitive reactance is 27.6 ohm. For capacitive reaction, one more formula is Xc equal to 1 divided by 2 pi Fc. So what we need is C. So exchange these two. So C equal to 1 divided by 2 pi F into Xc. Now we substitute all the value. 2 into pi into the frequency is 60 Hertz. The Xc value what we calculated is 27.6. So by simplifying this, what we got, 96.19 into 10 to the power minus 6 farad. So this 10 to the power minus 6 can be written as microfarad. So 96.19 microfarad. So now we calculated the capacitor value. Now we'll go to the power factor. Power factor cos pi. Power factor is nothing but cos pi, that is equal to R divided by Z. From the impedance triangle we can found this relation. So first we will find the Z value. R value is known, R value already given, but Z value we need to find. Z is nothing but V divided by I. V is 230 divided by 7.5, I 7.5, that is 30.75 ohm, right. So when you calculate, now we calculated the impedance value, that is 37.5 ohm, 30.7 ohm. So the power is given, W equal to I square R. From that, R equal to W by I square. So 750 divided by 7 point square, it is 13.33 ohm. So the R value is 13.33 ohm, right. So the power factor is cos pi equal to R by Z. First we calculated the Z value, impedance. From the power given, power dissipated in the resistor is given 750 watt. By using that we calculated the R value also. Now we can calculate the cos pi. Cos pi equal to R divided by Z. R is 13.33. Just now we calculated. Then Z 30.7 impedance. So by simplifying, what we got, 0.434 leading. Because of capacitive circuit, the current is leading the voltage, so it is given as leading. So the cos phi power factor is 0.434 leading. Now we calculated all the values, capacitor as well as the power factor. So in this problem we discussed the solved problem based on the RC series circuit. Thank you. Welcome viewers. In this video we will see the solved problem based on the RLC series circuit. Resistor, inductor and capacitors are connected in series. For that circuit we will see the solved problem. First we will see the problem 1. A coil of resistance 10 ohm and inductance 0.1 Henry is connected in series with a capacitance of 150 microfarad across a 200 volt 50 Hz supply. Calculate the inductive reactance of coil, capacitive reactance, current and power factor. We need to find these parameters. So the given data are, the resistor value is available 10 ohm, inductor value is 0.1 Henry, capacitor is 150 microfarad, that is 150 into 10 to the power minus 6 farad. Micro means 10 to the power minus 6. The voltage is 200 and the frequency is 50 Hz. Now we will find the parameters one by one. The first one, inductive reactance. Inductive reactance is XL. XL equal to 2 pi F into L. So 2 into pi into the frequency is 50 and the inductor value is 0.1. So by solving this we will get XL equal to 31.4 ohm. Then we will go to the capacitive reactance. Xc equal to 1 divided by 2 pi F into C. So 1 divided by 2 into pi into the frequency is 50. The capacitor value is 150 into 10 to the power minus 6. So by solving this we will get 21.2 ohm. So the capacitive reactance is 21.2 ohm. Now we'll find the reactance. The reactance X is nothing but XL minus XC, difference between inductive reactance and capacitive reactance. So these two are we already calculated. So inductive reactance 31.4 minus capacitive reactance 21.2, that is equal to 10.2 ohm is inductive, because the inductive reactance is more, capacitive reactance is lesser. So this will act, the circuit will act as a more inductive, so that it is given as inductive. Then we will find the current. Before finding the current, first we will find the impedance. Impedance, the magnitude of Z equal to square root of R square plus X square. From impedance triangle we can find this relation. Now we will substitute R equal to 10 and X equal to 10.2. So square root of 10 square plus 10.2 square. By simplifying this we got 14.28 ohm. So this is also inductive. So from the inductance value we can easily calculate the current. Current I equal to V divided by Z, voltage divided by impedance. So 200 divided by this impedance, what we calculated, 200 divided by 14.28, that is equal to 14 amps. The current flowing through the circuit is 14 ampere. Now we will find the power factor. Power factor is nothing but cos pi, that is equal to R divided by Z. One formula is available from the impedance triangle. So R value is 100, Z value is 14.28. By simplifying this we got 0.7. It is lagging. Why it is lagging? The circuit is more inductive. For inductive circuit, current is lagging the applied voltage. So that this power factor is 0.7 and given as lagging. So now we calculated all the parameters. We can go to the second problem. A coil of power factor 0.6 is in series with a 100 microfarad capacitor. When connected to a 50 Hz supply, the potential difference across the coil is equal to the potential difference across the capacitor. Find the resistance and inductance of the coil. So one capacitor is available, 100 microfarad. The power factor is given. And another condition given is potential difference across the coil is equal to potential difference across the capacitor. We need to find the resistance and inductance of the coil. So from the given diagram we can easily understand. So this is the coil that is connected in series with the capacitor. So this coil contains inductance as well as resistance. Normally the coil means inductance, but it has some amount of resistance also available. So this is R and L connected in series. This combination is the coil that is connected in series with the capacitor. So the condition given is the voltage across the coil is equal to voltage across the capacitor. V coil is equal to Vc. So that is the one condition given. And power factor is given as 0.6. The capacitor value is given 100 microfarad, that is 100 into 10 to the power minus 6 farad. The frequency is 50 Hz. So the problem is we need to find the value of resistance R and inductance L. So this R is the resistance of the coil, L is the inductance of the coil, Z coil is nothing but impedance of the coil, total impedance of the coil, right? So from the given condition we will start the problem. V coil equal to Vc, voltage across the coil is equal to voltage across the capacitor. So V can be written as I into Z coil, V equal to IR. Similarly Vc equal to I into Xc. So I got cancelled. So Z coil equal to Xc. The Xc formula is available, 1 divided by 2 pi Fc. So we can substitute the value, 2 into pi into the F is 50 Hz, the C is 100 into 10 to the power minus 6. The capacitor value also given. So by simplifying this we got Z coil equal to 31.8 ohm. The impedance of the coil is 31.8 ohm. So we calculated the impedance. Then another value given is cos pi coil, that is the power factor of the coil is 0.6. So this power factor cos phi can be written as R divided by Z coil. R divided by Z, here R divided by Z coil. From the impedance triangle, the formula is available, power factor equal to R divided by Z. So that is equal to 0.6. Now we cross multiply this, so that R equal to 0.6 into Z coil. So Z coil value is already available, 31.8. So R equal to 0.6 into 31.8. So by multiplying these two, we got 19.08 ohm. So the R value is now we calculated. R equal to 19.08 ohm. Now we'll go to the inductor value. For inductor, first we'll calculate the Z coil. Impedance of the coil equal to R square plus XL square. So by square on both the side, Z coil square equal to R square plus XL square. We need XL square, so we can write Z coil square minus R square. Right? This R square is taken into that side. So XL square equal to Z coil square we already calculated 31.8. R value also just now we calculated 19.08. So by simplifying this, we got 25.44 ohm. The inductive reactance XL equal to 25.44 ohm. This inductive reactance also written in another form, XL equal to 2 pi F into L. So the inductive reactance we calculated 25.44, that is equal to 2 into pi into the frequency is 50 into L. This L is we needed. So bring this term in the denominator. So L equal to 25.44 divided by 2 into pi into 50. So by simplifying this, we got 0.081 Henry. So that can be written as 81 Henry, that is millihenry. Milli means 10 to the power minus 3. So now we calculated the inductance value also. So in this problem we calculated resistance and inductance of a given coil. By based on the given condition, the value of R and L is calculated. So in this video we discussed the solved problem based on the RLC series circuit. Thank you.